Find the derivative of sine 2x tan x. Okay. Now when they say that, they mean sine 2x times tan x, which means this is a product, which means we're going to be using the product rule when we differentiate it. So, the product rule says you do these things as first sine 2x times derivative of the second, and the derivative of tangent is secant squared. So that's first d second plus second tan x. And derivative of the derivative of sine is cosine, so we get cosine 2x. And then the chain rule says do the derivative of the 2x, that gives us a 2. That wasn't an issue with this derivative because the derivative of what was inside here was just 1, so it was safe to ignore it, but it's definitely not safe to ignore it too. So, can we clean this up at all? My favorite way to decide that is rewrite everything in terms of sine and cosine, at least temporarily. So sine 2x, that's already a sine or a cosine, leave it alone. Secant is 1 over cosine. So what we have here is 1 over cosine squared x plus tangent is sine over cosine. And then we have cosine 2x. And then we have a 2, which I'm just going to put out front. That's a better place for coefficients. So, does anything cancel? Short answer, no. We have cosine over cosine here, but because their arguments don't match, we have 2x and x. Those are not similar. We cannot cancel them. Same, well, here we have sines versus cosines. There's no way to cancel that or combine them in any way. So, really, we can't do a great deal to clean this one up. The only thing I'd recommend you do is take this 2 and put it at the beginning of its term, and other than that, just let this thing lie. Secant squared x plus, there's the 2, tan x cosine 2x, done.